Thank you, Lisa. Well, it's really an honor to be here. Let me tell you, when I heard about the other speakers who had preceded me, I'm kind of humbled. So don't know how I'll pull this off, but I'll try. I'm normally a particle physicist, an experimental particle physics person. So what I do is I collide protons together at really high energies with superconducting magnets, with billions of channels of electronics and tons of CPUs linked together with fiber optic links. We find things like the God particle and that kind of stuff. So you might wonder, how did I end up on this topic? And I'll tell you. And in fact, people were asking me this at the reception. So this is a starting point for me. So this is a little map of a place called Little Cranberry Island, which is off the coast of Maine. And I'd been there a couple years before 2003 and did a little kayaking around. And this one year, 2003, I rented a kayak from the woman who ran the post office in Little Cranberry in the town of Islesford right here. And she was out of compasses and out of maps, but I thought I knew my way around reasonably well. And one day I decided to do a little circumnavigation of Little Cranberry Island. Now I can tell you that this is an interesting stretch of territory. To the south is the open ocean, actually the Gulf of Maine, so there's nothing, for thousands of miles if you go in that direction. And the waves wrap around this island, Baker Island, so that they're breaking from the left and from the right in these shoals here that get close to uncovering at low tide. In any case, I was crossing this embayment, and it's about 2 miles from this point to these shoals here between Baker and Little Cranberry, and I was in the middle, and without a compass, without a map, and all of a sudden fog started to roll in. And I said, "You dumb son of a bitch, what are you doing out here?" So what do you do? I've read elsewhere that people who are in survival situations, there seems to be a psychological characteristic that distinguishes people who survive and people who don't. Evidently, the ones who don't tend to become dogmatic, and they latch onto just one thing and follow that one thing into the ground. The people who survive tend to open up, and they'll even say that time felt like it was standing still, and all of a sudden their senses are opened up, and they're receiving all these thoughts and trying to assemble them. Well, I was certainly nervous, but I realized that if I didn't do something, I was going to end up basically drifting around and a rock ledge way out here, and they would find me in not such a good state. So I thought, and I could feel the wind blowing from the southeast, which would act like a natural direction indicator, and there were swells coming in from the open ocean from the southwest, perhaps the result of a distant storm or hurricane or something. And then there's a beach up here, which is this rocky berm about 20 feet high, and the rocks on it are sort of like rounded football-shaped boulders, I guess, for lack of a better word. And when the waves crash on this beach and the water recedes, it makes this loud grinding noise, and it's very distinct, and you can hear it from miles away. So I had 3 ways of orienting myself, and I knew that I was about a mile from this passage here, and I paddle at about 3 knots, which is 3 nautical miles per hour, so it would take me about 20 minutes to get there. So I used these natural compasses, and I could also sense the passage of sound from this rocky beach as I was making my way through the landscape. This is not a kind of a colored blob. This is actually a photograph of fog. You could actually make out some features here, but literally I could not see a distance across the stage. I was literally just going on sound and wind and swell, and when I saw the waves breaking over these shoals here and then breaking in the opposite direction, I was relieved. And then I found that lobstermen will only place their buoys so close to land, and so there was a little demarcation zone between the area close to land in the shallow waters and the area outside where you could see the lobster buoys. And this would form a natural line, and I followed that around and could even see little V's in the wake of the lobster buoys from the incoming tide. So I made it back in one piece. So that was good. However, there is now the sad part of this. I'm just going to warn you. Columbus Day weekend, I was at my house in Harwichport, and I had a recreational kayak down there, and I did not have a compass, which again seems kind of foolish in retrospect, and I went out and started paddling along the coast here. Now, the coast runs east-west, and I did notice the wind direction as I went out, and it was quite clear, and what should happen, but a fog bank rolled in again, and so I had noticed that the wind was coming out of the southeast again, and anytime I got out of sight of land, I turned my kayak to the north and then just could handrail my way along the coast here until I found my way back home. So that was fine. I pulled up the kayak, went in, took a shower, went out to a movie, had dinner with my kids, all was well. The next morning, I went out and I started paddling, and it was clear, and the harbor master was in this vessel that's a boat, and it looks something like a floating police cruiser, and he turned on the siren and has these flashing lights, like he was pulling me over for speeding or something. And I paddled up to him, obviously wanted to get my attention, and he asked, "Have you seen two young women in kayaks?" And I said, "No, I haven't." And he said, they went out yesterday from Ayers Beach. And I said, "Well, I live a quarter mile from Ayers Beach." I said, "When did they go out?" And he said, "Oh, about 3 o'clock." And I said, "Oh, God, I went out then, too. I was clear, and then it got really foggy." And he said, "Yeah, that's the problem." So there were two young women, ages 19 and 20 years old, who went out in recreational kayaks very close to where I was, and they told their boyfriends they would be back in 10 minutes, and the fog bank rolled in, and they didn't return, and after 45 minutes, the boys called the authorities, and just about anything that floats got put out there searching for the girls, and nobody could find them. And I remember the next day there was a Coast Guard helicopter that was going up and down this area called Nantucket Sound, and the authorities found their two empty kayaks tied together, but no evidence of the girls. The parents of the young women said that they actually were lifeguards. They'd had lifeguard training, and they'd actually had gone to a kayak school, and I had had neither. And then the next day, they found the body of one of the girls, never found the other one. And I guess I went back about a month later, close to Thanksgiving, and the mother of the girl whose body was never recovered put a little plaque at Ayers Beach that had her picture on it, and the saying underneath that no one is lost to God. And I just felt the weight of the world on my shoulders at that moment. And it's kind of hard to describe the feeling of survivor's guilt, because I was doing the exact same thing in the exact same place at the exact same time, and I was having a good time. And the idea that some people were struggling and lost their lives was almost too much for me to bear. And my first instinct was to ask the question, why? I mean, it seems like a normal human thing to do, and try to look for some sort of meaning in what happened. But what do you turn for meaning? I mean, if you just look at the waves, they crash and they make a noise and they don't offer up much in the way of meaning. So I literally became obsessed for the better part of a year, and I guess the first thing that I did was I tried to do things like make my life safer in some way. So I memorized the positions of major navigational stars in the sky. I had this whole scheme that I worked out. I had little flashcards that I would take with me on the airplane when I was flying to Geneva for my experiment, and would say, okay, I know Arcturus is at 19 degrees north and this sort of stuff. And I got fairly good at navigating just by looking at the stars in the sky without even having to use an instrument. Wind direction, kinds of fronts that moved in, that sort of thing. And then what happened was I then learned that I was not alone. Other cultures had been doing this for eons. There are Pacific Islanders, wind compasses have been known all around through many different cultures, the memorization of stars, and Polynesians, Norse, Arab traders, they'd all been doing this, and I felt a real kinship with them. And then something even odder happened, and I realized that I was looking at the world differently. That all of a sudden, like walking across the parking lot in a shopping mall, I was looking at where the sun was in the sky and wind direction and all these other things, and I felt very much, I guess, saying you're in touch with your environment sounds a little bit trite, but these things were telling me something, and it wasn't giving me meaning in the sense of why these girls died, but it gave me meaning in the sense that there's a front approaching, or a meaning in the sense that this way is west, and this way is north, and this way is south. About that time, people were starting to get cell phones and starting to text on cell phones. And so you would see the development of the cell phone walk. And this sort of thing was, it was strange and it bothered me because it made me feel that people were getting progressively tuned out to their environment, and I actually got scared for their lives, okay? So I had this temptation, and I'm just gonna step off the podium just to be dramatic, but I wanted to go up with them and say, put that down, you're gonna die, you're gonna die. And I realized this was probably not a healthy thing to do, to go into Starbucks and do that. So what I did was I created first a freshman seminar at Harvard where I tried to teach these skills and also the linkages to the history and human cultures of navigation. And then I realized I couldn't do a freshman seminar in perpetuity because it's kind of light load. So then I developed it into this general education course that I called Primitive Navigation, where the word primitive was a deliberate irony, because in the 19th century, ethnographers would talk about primitive cultures. And in fact, in looking at them, they were anything but primitive. I mean, in a sense, if you're hypnotized by your cell phone, that doesn't sound terribly advanced to me. We always start out with a baseline of what people know and how good they are. And we find that when I teach these skills over the course of 3 or 4 months, that people actually become quite good at assimilating environmental clues and being able to find their way. And so I would posit that we all have these mechanisms in our brains which are designed to help us find our way, and we just haven't really been exercising them a lot recently. So I do a test at the beginning of my first lecture of the semester, and I do it to audiences. Now I want to ask people, does anybody object if I take like a group photo? I mean, because I might want to post it on Twitter or something like that. Okay, I'm going to ask you that again when I tell you what I'm going to ask you to do. Okay, so what I'm going to do is I'm going to ask you to close your eyes, not now, in a little bit, close your eyes, and then I'm going to give you verbally one of the cardinal points of the compass, east, west, north, or south. And I'm going to ask you to point in that direction and keep your eyes closed until I tell you to open them. And we're going to see how many people do well at pointing east, west, north, or south. Okay? So I'm going to take your photo. Now, does anybody object now? Okay. We're still good. Okay. So let me just cue up the little camera thing. I mean, this is good for something. It's got to be good for something. Okay, so where are we here? Okay, good. So, the other thing I'm going to ask you to do is, this is a kind of a statistical test for all of you, is keep your arms pointing in whatever direction, and I tell you to open your eyes and then look around your neighbors and see how your neighbors are doing in terms of this test. Is that okay? Okay, so has everybody got it? Okay. Okay, so close your eyes. Okay, now I'm going to ask you to point south. Okay, open your eyes and look around. So, okay. People do, this is about as well as most people do typically. I mean, I would say we were batting about 70%, right? Okay? So, we aren't that bad after all. It's, you already, in fact, assertions are made that Westerners can't even do that. I've seen, I've read from reputable or supposedly reputable people that Westerners are incapable of passing that test, that they will go into, they are not capable. They will fail that test. And you have just proven that cognitive psychologist wrong. So congratulate yourselves. So here is the first semester in primitive navigation. You can see everybody pointing south or west. I think it's south in this case, so they were pointing south. In fact, what was interesting is I was going to have you point west, and then south came out of my mouth, and everybody did it properly, so I'm even more impressed. I looked, I said, wait, oh yeah, I said south, okay, good. So among other things, I teach them how to memorize the positions of major navigational stars. They write it down in quizzes, and they have a little grid, and they plot the stars down on a grid. And in my midterm evaluations, they always complain that it's rote learning, and we're grown-ups at Harvard, and we don't have to do rote learning, and that sort of stuff. But we get them to, and this is a photo of them in the roof of the Science Center, and you might just make out this woman here looking up into the sky with a protractor with a, you can't really see the weight on it, but we take them up to the roof of the Science Center, and I say, you know, what's that star? And what's that star? And what's that star? And some of them will be able to, we can see 14 major navigational stars that they've memorized, and some of them can just nail it. But what's even more remarkable is you see this real epiphany where you've gone from this kind of, I don't know how to put it, you know, knowledge can be disembodied in little nuggets where you don't really grasp what it is, but when you grasp it as sort of a conceptual whole, there's an aha moment where all of a sudden it all falls together. And in the space of 10 minutes, you may see a student or many students have this aha moment right before you, and it's extremely rewarding for me. So that's the course, and so let me now go through just some of the elements of what I talk about. So the first question is, how do you organize your space? What's the stuff in your brain that is going to help you find your way? There are specific areas in the brain that hold the cognitive map. And psychologists, starting from a guy named Edward Tolman around 1948, tried to imagine that there was possibly root knowledge, which was the idea that there were these paths in your environment and little nodes that connected them, and that if you wanted to get from one place to another, you would travel down a path or route and then hit a node and then come out. So if I wanted to get from here to here, I would travel inward and then turn and come outward. On the other hand, one could imagine something different, which is survey knowledge, as if you had a map of your environment in your head, as if you were on a magic carpet looking down on top of everything, and you could visualize everything. And now the question is, how could you tell whether an individual possessed root knowledge or survey knowledge? And Tolman's idea was actually rather remarkable. It was shortcutting behavior. So when you first learn about a new territory, you'll typically have root knowledge. But when you learn in detail about a territory, you'll start to acquire survey knowledge. And the idea is that if I wanted to get from here to here, and I saw a road that was leading in that general direction, I would probably be tempted to take it, even if I didn't know for sure it ended up where I wanted to go, because it would be a lot faster than having to go into this traffic jam in Harvard Square here. This is actually an outline of the roads in Harvard Square. So this would be survey knowledge, I would claim. And what Tolman did was to put rats in a maze, get them learn a territory, and have food over at some point where they could find it, and then alter the territory a little bit where shortcutting behavior was possible, and found that rats indeed did shortcut. So there are these parts of our brain which seem pre-wired to have these two-dimensional maps, this survey knowledge that we have, and it exists in part of the brain called the limbic system. And there's actually, for those of you who are real savants, it's in the hippocampus and a neighboring region called the entorhinal cortex. I won't quiz you on that. But there is a part of our brain that is devoted to that. And a lot of neurosciences are fond of saying that Kant proposed these a priori concepts that our brains are basically wired up to absorb, like language being one and a cognitive map being another. So I've mentioned that shortcutting behavior demonstrates survey knowledge once you've learned the territory, and it turns out that mammals and birds and some fish have this survey knowledge, so rats, mice, wolves, people, but not ants and bees. They tend to have root knowledge. And at the risk of being, I always like to do this talk about wolves and dogs a little bit. Okay, so if I were to ask you, why do dogs pee on fire hydrants or trees, you would probably say that they're marking their territory, right? Turns out what they're doing is they're concentrating their scent in little, like kind of, you know, when you're walking through the forest and a trail, there are blazes. So you see a blaze every so often that tells you that you're on your trail. Well, what they do is they concentrate their pee, so a bunch of them pee in one little spot, and that smell at that one spot can be smelled maybe 50 feet away where they get to their next scent marking. So it's like a little set of blazes, kind of urine blazes, that they use to find their way from one place to another. And that's when they get together, you know, they all sniff their butts and things like that because they want to know who's on their trail. The guy who wrote a book that talks about survey knowledge on wolves and dogs, and I can direct you to the volume if you want. I think it's actually, I have the reference in my book, but if not, I can certainly get you the reference. Okay, so it was in a collection of papers on the behavior of wolves. Also, the claim, the same place. I mean, if you're a doubter, I'll get you get it for you. But this thing when they're doing this after they've done their business, apparently that's taking the scent off their paws and it's not burying the stuff. The idea being that they want to get from one place to another and not leave a scent so a predator can track them. So it's rather interesting evolved behavior. Obviously, we don't engage in that behavior, but our noses aren't that keen, and it probably would make for bad social skills, at least for us. Okay, so one thing that is intrinsic to our brains, and what's interesting about trying to figure out how humans found their way is there are all these little clues, some of which are buried in language. And the simplest way that people can find their position is start from a point of departure, where you know where you are, your home, let's say, and then you find your position from a known starting point and keep track of distances and directions. In nautical terms, the direction that you're moving is called a heading, and a bearing is the direction to an object that you've sighted, and a fix is an unambiguous determination of your position. So you may actually kind of get off track a little bit by not estimating distances and directions precisely, but you can have some idea of where you are. And our brain has this intrinsic way of kind of integrating the distances that we've been walking and the paths and so on, but can be articulated in words. Here's just a path of Christopher Columbus tacking against trade winds and doing actually a rather remarkable job of figuring out where he was. This is along the coast of what's now Honduras. So we can look at some natural, for human, units of distance, and if you dig into the etymology of these words, you can actually see where they originated. So counting paces, the word mile comes from Latin, mille pacem, and I wouldn't quiz this room because I'm sure I would get about 30 hands coming up that already knew that. Mille pacem means 1,000 paces, and so that's every time, let's say, my left foot hits the ground, that's a pace. Okay, so 2 steps is a pace. I take my students out and we test this out. We lay out a little distance, 100 feet, and have them walk and do an average over 150 students, and darn if that doesn't come out almost exactly at 1,000 paces. So if you're ever lost in the woods, all you have to do is remember a mile is 1,000 paces and you have a natural distance marker for you right there. Another thing which seems perhaps maybe obvious is that distance is velocity times time. The Egyptians established an hour as a natural unit of time, 24 hours in a day. Not all cultures have that, and we'll come to one that has a different, I guess, way of slicing up the time in the day. But an hour was pretty common. So if you travel at 3 miles an hour, in an hour you travel a distance called a league, which is about 3 miles. And the Arabic name for the distance that you travel in an hour is a farsakh. So here's another unit of distance, but it's based on something very simple that is in effect human if you can figure out time. Another is related to fatigue of oxen, would you believe, or fatigue of beasts of burden. So you think about plowing with an oxen ground. So you go along for some distance, and if you go too far, the oxen get tired and they're just going to go plop over. So you don't want to do that. If you turn it around too soon, it's quite painful to, get them turned around, and get the plow turned around, and get all the lines working and all that kind of thing. So you don't want to do it too early. So there's an optimum distance in some sense that allows the oxen to rest as you're turning around the plow and all that stuff. Turns out that's about 220 yards. And so the word furlong comes from the Saxon term for the length of a furrow, 220 yards. And it turns out that both in Egyptian and ancient Greece, there was a stad or stadia that was related to this as well. So this is another common human measure. And then drift in water, which is fairly similar, is velocity times time. Knots was just the practice of throwing a chip log, some piece of wood overboard, and letting rope pay out while you had a little sand glass. It was kind of counting time, usually about 30 seconds, and then there would be a set of knots that were spaced along, and then when your sand glass finished, you clamp down on the rope, and then you would just count the number of knots that had passed through. There were some knots that were tied on it. I could also count strokes when I'm kayaking or when I'm swimming. Okay, so humans don't really seem to have a natural compass in their head. We don't sense the Earth's magnetic field, but we use environmental clues to tell us directions. So there really is no GPS chip in our head like maybe birds have. But you can look at the etymology of words. So in Latin, oriens, which is east, has an etymology associated with the rising sun, or meridies, which is south, meridies literally means middle of the day, so the sun is at the south in the middle of the day. And occidents, which is related to the word occult, or occultation, is the setting sun. And the word for north is septentriones. The Big Dipper has 7 stars associated with it, and it looks something like a plow, and the idea was that you had 7 plow oxen that were pulling it along. So septentriones, sept means 7, and tentriones is associated with the 7 plows. In Northern European, Indo-European languages, est is associated with the rising sun. In Greek, Anatolon is rising and sun. North in Indo-European languages, if you're facing the rising sun, left is etymologically used for north, because if you're facing east, north is to your left. In Hawaii, the setting sun seems to have prominence, so north would be right and south would be left. And you have other clues. In Egypt, north would be downstream and south would be upstream. So this is just some examples of the fact that our senses of direction are coming from environmental clues. If you'd walked in here and you'd been unfamiliar with the area, you might have just looked at the sun setting in the west and just figured out where you were. And a lot of times this just happens intuitively without thinking about it terribly hard. Okay, so that's kind of the broad picture, but let's look at a couple of cultures, or several cultures, and see how people found their way. So one of the more challenging areas are the barren lands in the Canadian Arctic. And in particular, this region here, the Nunavut territory, which is in to the northwest of Hudson's Bay, is basically flat barren lands, and there are very little relief to it. And the people that inhabit a large chunk of this area are called the Netzilik. And here you see a photograph of the Netzilik hunter catching fish through a hole in the ice. And they actually have a remarkable sense of geography. There was an ethnographer, explorer named Knud Rasmussen, who made a trip through the roof of North America to document Inuit culture before it got encroached upon by Europeans. And he would go to Netzilik hunters and give them a piece of paper and a pencil. Now, they do know something about pictorial representations, but they'd never seen a pencil and paper before. And he would ask them to draw their territory. So here's a drawing or my capture of a drawing by a Netzilik hunter from Knud Rasmussen of King William Land, which is an island. And here is my outline of that from a satellite photo. And you can see that basically in the hunter's mind, he's capturing a lot of these features. This little nose here, this little nose here, these islands here, this fjord here, this fjord here, this little hook down here, this hook down here, these islands here. So does a remarkable job. having it in his head and being able to reproduce it. And the question is, how would they know to find directions? It's very challenging. You can be in blizzards, you can be in whiteouts, you could be in fog, and it's flat. Well, as it turns out, the wind direction can be a really nice clue. Sometimes, and I'll talk about wind compasses in a little bit, but as the wind blows over snow, it creates little ripples, and the ripples are perpendicular to the wind direction. And the time that it snowed and when the wind was blowing is going to affect the characteristic of these ripples. And so to a good approximation, if the wind had just dropped out and you were in a whiteout or a fog out, you could still know which way the wind had been blowing because you could follow these ripples. Another thing you can do is it's very difficult to find a point in a two-dimensional plane, but if you can find a line that leads to that point and then follow that line or that track, then you can find your way home. So what they would do would be to follow direction from these wind ripples in the snow, and then ultimately they would come upon one of the outward-going tracks of sledges, and they were very adept at being able to read these tracks. They could see the dog's paws, they could tell by how much the snow is layered up, how old the tracks were, and whether how heavy the sledges were, and so on, and then just follow it to their camp. So that's a fairly simple way of doing it. So I had been accused when I gave previous lectures of being too heavily oriented on navigational skills in the ocean in a marine environment. And so I kept wanting to find other clues. And in October, I was in Morocco, and I took camels out into the desert. Not just me, I had help with some Berbers to take camels out into the Sahara. And lo and behold, what did I see? But I saw these little ripples in the sand that were mimicking the direction of the wind. And I said, well, that's pretty cool. The same thing that the Netzelik used, the Berbers could have used. And this is sort of at a microscopic scale, but when the wind's blowing long enough over a large enough territory, you get these characteristic shapes of dunes, which have these kind of gentle slopes in the direction the wind's blowing from, and then these very steep drop-offs in the leeward side. And so with some study, you can actually find your direction using these wind ripples and the shapes of the dunes. So I found that to be rather clever. Okay, so I'm going to turn a little bit to the Norse, and I'm going to try to focus on just one little passage in the saga of the Greenlanders that speaks to their use of the sun. Now, they would typically, in order to navigate, let's say they wanted to find a spot in Greenland, like the Western settlement, or the Eastern settlement, which is down in this little corner of Greenland, they would sail north to a spot that was at the same latitude in Norway as their target destination, and then sail due west, try to keep west as best they could, which meant they had some way of finding direction. And then they would hit the spot in Greenland that they wanted to. In fact, in this particular set of directions, they would be bisecting the Shetland and Faroe Islands, and they would see sea life near the mid-Atlantic ridge from upwelling near Iceland. And we know for a fact that they made it at least as far as Newfoundland and probably even further south to Cape Breton and perhaps to Maine from both archaeological remains and the Vineland sagas. Now, they would voyage in the summertime, and their pathway was probably cleared by something called the medieval climate anomaly that caused a warming of the North Atlantic and a reduction of the amount of sea ice. And then their colonies were shut down in Greenland at about the time of the Little Ice Age. But they would probably voyage during the summer, and at those latitudes, you basically can't see any stars because it's just too bright out. And there are other reasons why it would be difficult. So they probably used the sun as a way of finding their way. So let's talk about the sun a little bit. So in Boston, I should have drawn this for Kansas City, but it's not going to look terribly different. What's our latitude here, by the way? I should have looked it up. Is it like 39 north? 39 north. Okay, so that's not too bad. So we're at 42 north up in Boston. So if you can see the difference between here and there, I'll give you a prize. So one of the reasons it's cold in the winter and warm in the summer, which is, I will tell you that 21 out of 23 Harvard graduates got this answer wrong in interviews in 1987 at commencement, is because of the axial tilt of the Earth. And its orbit around the sun. But if you asked a Neolithic farmer, they would just say, the sun is low in the sky, and the angle of the light is low at the winter solstice, and so it's cold and the days are short. So here's the path of the sun from the east to the west, crossing this dotted line called the local meridian, which is the highest point that the sun gets to in the sky, and that's not terribly high. So it's probably about, maybe 26 degrees, 27, 28 degrees here in the wintertime. Then at the equinoxes, it passes higher in the sky, rises due east, sets due west. And at the summer solstice, it rises to a much higher point in the sky, and so the sun's rays are coming down more direct fashion and warming things up. Now, this is a clue to where we are, because the path that the sun makes in the sky at these different times of the year is actually going to tell you something about your latitude. So here we are in Boston at the summer solstice, and here was just that path that I drew. If you were to go to Caracas, Venezuela, the sun would nearly cross your zenith and actually would be a little bit north of your zenith, and it's very direct. And at Narvik, Norway, which is at 60 degrees north, you would have this much lower angled orbit, and in fact, it completely orbits the sky in the summertime, and you can't see it because of the podium. I'm sorry, I don't know what to do. Well, just take my word for it. There's a depressed orbit in the sky. Okay. So some of the things that you can now take away is the length of day is a function of your latitude. And so at the summer solstice, this is particularly true. At the equinoxes, it's not true. At the vernal equinox and the autumnal equinox, every part of the Earth has the same length of day, which is 12 hours. But when you get to the summer solstice, you get a fairly profound dependence on your latitude. So, for example, if we're here at 39, the length of day at the summer solstice is, going to be a little bit over 39, 35. So yeah, it's going to be about 14 hours long or something like that. And 24 hours long when you get above the Arctic Circle, and you have eternal darkness when you're below the Antarctic Circle at the solstice. So there's a strong dependence of the length of day, and if you wanted to go to the wintertime, you just flip this figure around and find that you have a fairly small length of day, short length of day in the winter. There's also another effect, which is something called the amplitude of the sun. So the sun rises due east at the equinox, and it rises south of due east at the winter solstice in the wintertime, and it rises north of due east in the summertime. So keep that in mind. And here is the maximum excursion of the sun from due east at the summer and winter solstices. And so it's about 23 degrees in the tropics. It's maybe 32 degrees, actually maybe around here, and it gets quite large as you go up further north until you become circumpolar. And here's a photograph out of my back bedroom window. The sun, this is looking west, so the sun sets here December 21st to the south, here February 21st, and here due east in March 21st. And if you were to go up to the Arctic Circle, you would see something like this at around midnight, so the sun never sets. Okay, you with me so far? Okay, you all on board? Okay, okay. Now, what the heck is this up here? Okay, this is from the Saga of the Greenlanders, and I'm going to tell you that you're going to understand what this says in a second, or a few minutes. It's describing the characteristics of the sun in Vineland, this new land that they came to in North America. But to understand this, you first have to understand how the Norse told time. So the sun, because it had this depressed trajectory in the sky, actually acts like a natural clock. So if the sun were north, like in that photo I just showed you, here, at the lowest part of the sky, it would be midnight, midnighti. If it is in the northeast, it would be 3 a.m. Ata. If it was due east, it would be Midder Morgen, which is 6 a.m. If it was to the southeast, it would be Dagmal or Daymil, 9 a.m. High Degi, high day, which would be to the south. Eikt to the southwest, Mid-Afton to the west, and Nattmal, night meal, to the northwest. And they would literally, in Icelandic farms, up and through the 19th century, would have markers. So you might have Daymil Hill or something like that. Or if you were looking out from the front door of your farmhouse, you might have a cairn or a pile of rocks, And that cairn or pile of rocks might mark dagmal, which would be day meal, 9 a.m., and you would be able to tell time from that cairn of rocks. And these locations would be given the suffix stad. So dagmal stad would be the position of the sun when it's in the southeast. So now we can start to understand this a little bit. Mira var, this is like a TH here. Mira var thar Yafen Dogri in a Greenlandi et Islandi. So they're describing the characteristics of the sun in Vineland, this new land, which is quite substantially south of Greenland and Iceland. Yafen Dogri basically means equal days. And now in modern Norwegian and Icelandic, it actually, something very close to this means equinox. So it says the days were very nearly equal than in Greenland and Iceland. That's what the first sentence means. And here the sun sol hafti par Eiktarstad og Dagmalstad Skamdegi. So what this means is the sol is the sun, passes through, and Skamdegi means short days. So short days is the winter solstice. Makes sense, days are short. The sun passed from Dagmalstad, from here, the southeast, to Eiktarstad, Eikt point here, in the short days. So the days were longer, or the days were more equal than in Greenland and Iceland, and the sun passed from the southeast to the southwest in the short days, which they most certainly didn't do in Iceland. So the author of this passage was trying to draw attention to the latitude of the place they were, and any of the Vikings who had voyaged, some of them who had voyaged through Iceland, had also been to Dublin, and so they knew the characteristics of the sun in Dublin, and this would be basically a nod to the fact that they were at a similar latitude to what they would have been in Dublin. So it was a way of marking position using the sun, so kind of a way of getting latitude. Okay, so am I allowed to continue?
Yeah.
Okay. So you get a bit of a choice here, because I don't know how long it's going to stay there with not getting me the hook or something like that. I have wind compasses, I have wave piloting in the Pacific, and I have some cool stuff with latitude. So I don't know, what do you all feel like hearing about?
Everything.
Everything. I'll try my best. Okay, I'll try my best. Okay. Wind compasses. So wind saved my life when I was out in the islands, and as it turns out, a lot of cultures have wind compasses. So this is called a windrose, and it basically is a representation of which way winds are blowing. And the length of this thing tells you that you have most of the days of the month are coming from a certain direction, and this is in Logan International Airport. So in the wintertime, you tend to get cold, dry air, which is coming from the middle of the continent of North America. And so the winds typically, the prevailing winds are from the northwest. In July, the typical prevailing winds are coming from the Gulf of Mexico, and they're warm and wet, and they're coming from the southwest. So the character of the wind gives you a clue to its direction. And so you can make a natural wind compass out of it. Here you see kind of an interesting transition. So we have April, where you're still getting a lot of cold winds out of the northwest. May, things go nuts and winds coming from any direction, and June, things start to settle into this southwesterly pattern. And so, that's why the month of May has this characteristically unstable weather that we associate with the month. So we aren't the only ones in Boston that could make a wind compass. This is from anthropologist friend of mine, Rick Feinberg, who studied the island of Anuta, which is in the Eastern Solomons, and they have a wind compass. I'll just point out two of the directions. Tonga Maro is the trade wind direction. The trade winds in this region blow from the southeast to the northwest. And you can identify the trade winds by a characteristic shape of a cloud called a trade wind cumulus. And I'm sorry for you folks over there that are kind of knocked out of the visual field. But it has this characteristic flat shape on the bottom, and it kind of heaps up in the direction that the wind's blowing. And if you see these clouds, you know that the wind's coming from the southeast. Pakatiu is kind of the stormy season in November, and it has flat clouds, and they're rainy, and they look a lot different. And so you could distinguish a northwest wind by the rain that it bears and the shape of the clouds from a southeast wind, this Tonga wind that's coming. By the way, Tonga is not only the direction, it's an island cluster. The Republic of Tonga, and it's southeast. So it does the word does triple duty in Newton. In the western Mediterranean, there's a similar wind compass. I'll just mention one, the Mistral wind, which is caused by a high pressure and a low pressure system forming off the Bay of Biscay in the North Sea, and it gets funneled down the Rhone River Valley and creates these strange shapes of trees that get wind blown in there. And probably one of the more famous ones is the wind compass that the Greeks had. So Boreas, the god of the north wind, is associated with wintertime, and here you have the famous wind tower in Greece. This is Boreas, and down here is Chiron, the northwest god. So that's associated with winter and cold, dry air. And then Zephyrus, who's the god of spring, sort of a god of spring, which brings warm, wet winds from off the Mediterranean, and flowers follow. And then in the summertime, the hot winds coming from the south, Notos is associated with that. And so just to show you that I'm a Renaissance guy, so here's this famous painting by Botticelli called Primavera. And here you see Zephyrus in this characteristic, the cloud, kind of color of clouds you see in the springtime that are gray and they bring rain and everything. So Zephyrus in the poem Fasti by, blanking on his name, Ovid. Ovid, so Zephyrus ravages, rapes Chloris, but then does the right thing and takes her for his wife, and then surrounds her with all these beautiful gardens. So you see Zephyrus taking over Chloris, who later, through some strange miracle of transliteration, becomes Flora. Now, I would ask normally an audience if they can identify the other navigational related clue in this painting, but I'm going to just tell you the answer. This woman here representing Venus was supposedly the model for Venus in this painting was Simonetta Vespucci. And if any of you recognize the name Vespucci, you'll know that that name is related to Amerigo Vespucci. It was a distant cousin of Simonetta Vespucci, and realized that North and South America were actually a big continent and distinct from Asia, as Columbus thought it was Asia. So that's why it's America and not Columbia. Okay, so there are wind compasses. I can't go into great detail, but there are a couple of nice little bits about the equatorial Pacific that I can't miss, and then I'll just do a little riff on latitude and longitude for you. So the hegemony of the Polynesians in the Pacific Islands is remarkable. They started out from the Bismarck Archipelago probably around 1600 BC and started making jumps out of sight of land, and they had to sail against the wind. And at first, sailing against the wind may sound counterintuitive, but if you tack against the wind and then you have to turn home, you're guaranteed a free ride home. But if you go, with the wind, Lord help you if you want to turn home, because, forget it. So they made jumps to the Santa Cruz Islands, to Fiji, to Samoa, Tonga, Tahiti, and the Marquesas over a course of from about 1600 BC to about 600 AD. And these were jumps that were about 500 miles. But then they started making these jumps of 2,500 miles from, say, Tahiti and the Marquesas to Hawaii, okay, perhaps following the trail of migrating birds. But they had to have evolved some incredible navigational schema in order to do that with some reliance. And the radius of operations of the Polynesians started to shrink around 1300 AD, and by the time Westerners came in contact with them, we only saw navigation among island groups like the Marshalls and the Gilberts and French Polynesia, but we are able to still glean a lot of what the, let's say, the circa 1000 AD Polynesians had in their toolkit. So Rick Feinberg, who I already mentioned, and his student Kathy Pyrick came up with this concept of a navigator's toolkit, where no one sign can be perfect, but when you use many signs together in combination, you can find your way with some assurance. So a star compass, which I'll explain to you in a second, was one component. There's a mystery called underwater lightning, which we get to the questions I can talk about. A wind compass, which I just described to you. Wave piloting, well, I'll talk a little bit about in a second. Cloud formations and birds. Some species of birds, like frigate birds and pelicans, will fly outward of 50 miles from an island. And if you can just roughly make your way in the direction of an island and see a bird that's feeding, if it's a pelican, you stop, you wait till dusk, and then the bird will fly to land, and you can find your way to land that way. So it's a kind of successive approximation. You start with stars, and then by the time you get to seeing these birds returning to land, you basically can make landfall. So a star compass works near the equator, and the territory that these people were inhabiting and exploring were between 20 degrees north and 20 degrees south latitude. So this trick works well near the equator, where the stars always set and always rise at the same relative position. So if we took, let's say, Betelgeuse, which is at 7 degrees north in declination, it always rises 7 degrees north or 7 degrees north of due east, and sets 7 degrees north of due west. And so you can use that as a compass point and use that at nighttime to find your way. How do you find your way during the daytime? Well, in the Marshall Islands, they used waves, evidently, waves that refracted around islands and reflected off of islands. The first Westerner to note this was a German bureaucrat who called himself Captain Winkler. And he was in the Marshall Islands. He found these strange charts, and he didn't know what they were. He called them stick charts, and nobody would tell him what the heck they were. And finally, he gained their confidence over time, and the navigators there in the Marshall Islands allowed that these were diagrams of how waves reflected and refracted around islands, and would actually make a very distinct pattern. And if you knew what was going on, you could find your way. So here is just one example. Let's say we have a swell coming from the east, driven by the trade winds, and here these lines represent sort of the crests of the waves of the swell. And as they reach shallow water, they start to get bent around or diffract. And so the northern part of these waves would get diffracted to the southwest, and the southern waves that are getting refracted around the island are getting pushed towards the northwest, and you get this crossing pattern of waves. And this is called Nittenkot, and the idea of this crossing pattern of waves is supposedly resembles a cage that fighting birds are kept in, which is what this actually means on land. And so you could imagine that if you were seeing these crossing patterns of waves, that you could then follow a certain direction to get to the island. So that's just sort of a thumbnail view of wave piloting in the Marshall Islands, which I've done a lot of work with anthropologists. Okay, so finally, and I'm going to wrap it up, promise, a little bit about where latitude and longitude came from. So I assume that most people know what latitude and longitude is. I'm not pandering to you, but I just want to say a few words about it. So latitude is the angle from the equator going north and south, and you have parallels where these lines of latitude, constant latitude, ring the Earth and encircle the Earth. Then you have longitude, which is an angle that extends from something that we arbitrarily call the prime meridian, which now goes through Greenwich, but it's totally arbitrary because the Earth rotates. And these lines of longitude converge at the North Pole, okay? And typically we express a location in terms of a pair of coordinates. So Boston is 42 degrees north, 71 degrees west. Now this comes from the ancient Greeks, and the idea of latitude was derived from a concept called climes, where basically everything would be more or less the same in terms of people's skin color, the kinds of trees that grew, the length of the day at the summer solstice would all be the same at a given clime. And then eventually these strips of climes became turned into mathematics of the angle of latitude. The other concept that the Greeks had was that the occupied part of the Earth, the Oecumene, was surrounded by an encircling ocean. And there was a westernmost point that you would derive the 0 for longitude, which were called sometimes the Fortunate Isles or the Blessed Isles, which was a kind of Elysian fields where people would go on their way to the great beyond, I suppose. So it was the westernmost point of land known to people. And that was the schema by which longitude was reckoned. And as far as Ptolemy was concerned, only 180 degrees of land were occupied by intelligent people. And so this got emblazoned into the thought processes that were later passed on to the Arabs. Now, I guess I could ask you the question, but again, for sake of time, I probably should keep moving. But what do you think latitude and longitude was used for in the Middle Ages? Okay, does anybody have a clue? I probably just gave it away. Yeah.
Religious journeys.
Religious journeys. Close. Astrology, yes, exactly. Two things, actually, you're close. So facing Mecca was one of them. If you wanted to face Mecca, you have to think of it as a set of great circle routes. So you know how if I said, I want you to pray to the North Pole, you would all turn that way and you would pray toward the North Pole because that would be a line of longitude. Now, imagine Mecca as being kind of a religious North Pole, okay? You can imagine a set of lines of longitude all converging on Mecca, and if you knew how to face that way, you could then pray facing Mecca. In order to figure that out, you had to know your latitude and longitude and a little bit of spherical trigonometry. So that was one. The other one is astrology. Not astrology as you pick up the newspaper and you say, you know, well, I'm a Pisces, and I go, look, you know, I'm always at the bottom of the damn thing, which irritates me no end, but I've gotten used to it. So that is your sun sign. So when you're born, you know, on that date, the sun is in a particular sign of the zodiac, and that's your sun sign. But natal astrology is somewhat more complicated, and it has not only the positions of the sun in the zodiacal signs, but the positions of the planets in the zodiacal signs on the day you were born, the moment you were born, but actually something even more complicated called houses. So some of you may recall the song from the musical Hair, The Age of Aquarius, where they sing, you know, when the moon is in the 7th house and that sort of stuff. Well, as it turns out, houses are a projection of the ecliptic in the sky at the moment of your birth. So if you know the moment of your birth and your latitude, you have this house system. So the eastern horizon is the boundary between the 12th house and the 1st house. And then as you go down, you sweep through the nadir, which is the point directly underneath us. You get the first 6 houses until you hit the western horizon. And each one of these houses is some aspect of your life: children, parents, brothers, wealth, health, and so on. And then you go from the western horizon through the midheaven, sort of the zenith point, if you like, approximately through the 12th house. And you have other characteristics like spouse, journey, kingdom, friendship, and so on. So I tried once to do a natal horoscope chart for a friend because I wanted to learn how it worked. And so just to give you an example, when I did her chart, I found out that she had Venus in her kingdom house and Mars in her spouse house. And so now maybe I should just explain a little bit that having the god of war in your spouse house is not necessarily a good thing in terms of marital relationships. And she said that explained a lot, and I didn't want to pursue the matter any further. Point being that I had to know the moment and the place where she was born to be able to figure out that Mars was in the 7th house for her. Okay. So how did people reckon latitude and longitude in the Middle Ages? So I'll just give you a simple example. So on the equinox, when the length of days are equal, it turns out, if you do the math, the path of a shadow of a stick, the tip of the shadow of a stick will actually trace out a straight line everywhere on the planet. Any other day of the year, it's going to be a different path, which is a hyperbola. And as it turns out, at the point of closest approach, if here's the stick and here's the shortest shadow at that time of year, this angle is exactly equal to your latitude. And so the common way of determining the latitude of a place or a city was to put a stick in the ground and then basically measure the path of the shadow. So when I'm on vacation in Jamaica, instead of reading spy novels, I happen to be down on the vernal equinox, instead of reading spy novels, I find a stick, I put it in the ground, and I lay out little pieces of coral in a straight line following the shadow and determine my latitude, which looks odd, but over time I attract people's attention for better or for worse. So here's this, I did this in this equinox this year and laid out a string and then got the distance of closest approach, and sure enough, I got my latitude to a degree. So that works pretty well. Now, I was able to find a publication by a geographer who had found himself a table of latitudes and longitudes from the 12th century by an Arab astronomer named Al-Zakhali from Toledo. So these are called the Toledo and the Marseille tables. The Marseille tables when they're in translation. And they have all these interesting places like Tolatin, which is Toledo, Alexandria, which is Alexandria, Sana'a, which is the capital of what's now Yemen, Serendin, which was Sri Lanka, and some other strange places like Sigdamesa, which was the northern terminus of the trade route of gold being carried from the Empire of Ghana across the Sahara. And then the question is, what was the prime meridian? Was the Fortunate Isles somehow in there? And people had assumed, historians had assumed that the Fortunate Islands were probably the Canary Islands off the coast of Africa. So I decided to put it to the test. Now let me explain something about longitude, which is kind of curious. It's very difficult to determine longitude because we're on this spinning round table. So we're spinning around, so the sun might be shining directly down on the prime meridian at noon Greenwich Mean Time, but then 2 hours later, it's shining directly down on the meridian at 30 degrees west, and 2 hours later, it's shining down on the meridian at 60 degrees west. So you would think you could only do it if you had a clock. There's some way to figure out longitudes without a clock, perhaps. So in the Middle Ages, one idea was using the timing of lunar eclipses. And curiously enough, if you go down where we had the reception, there is this treatise by Gemma Frisius. And in that treatise, he talks about using clocks to find longitude. And if you see the page that it's open to, you'll actually see a diagram of a lunar eclipse. I just was down there and looking at it. I was like, wow, that's cool. It just like fits right into this lecture. So a lunar eclipse will be seen to be the same everywhere on the planet. It'll always happen at the same time, and that's when the moon slips into the shadow of the Earth. On the other hand, the timing between the sunset and the eclipse is going to be different depending on your longitude. And so that acts like a kind of clock. So in principle, if you can do the timing between the sunset and the eclipse, you could actually determine your longitude. Columbus did this when he was marooned on his 4th voyage in St. Anne's Bay, Jamaica, and did not so well, but it is passable. Instead, what people probably did was use dead reckoning. So when people would arrive at a major city, they would report, they'd say, hey, how long did it take you to get here, right? And, oh, 6 days. And over time, if you had an assiduous geographer, they would actually copy all these down and then try to assemble them and try to get, a table of longitudes together, but it wouldn't be terribly precise because it would be based on dead reckoning. So I took this table of latitudes and longitudes from the Middle Ages and then just did like any good physicist might do, put it into a spreadsheet and tried to calculate what was the precision with which latitude was measured, what was the precision with which longitude was measured, was the zero of latitude consistent with the equator, and what was the darn prime meridian. So when I looked at the typical standard deviation, that's the spread of the data for latitudes, it was about 1.4 degrees, which I would claim is consistent with the shadow stick method that I just told you. The longitude standard deviation was much larger, 6.5 degrees, and with some thought I figured that actually was consistent with dead reckoning and some poor scribe having to put down all this information and assembling it consistently. Now, the latitude difference, so you gain statistics. When you get 30 points, you can actually find the mean of the distribution much better. So if I look at the difference between the modern values of latitude and those values of latitude in the table, it was within error, 0.25 degrees plus or minus 0.27 degrees. That's consistent with the equator. But if I look at the modern longitude values and the difference with the table, I get a precision of about 1.3 degrees, and I get 23 degrees west longitude. The question is, what the heck is at 23 degrees west longitude? I can tell you it's not the Canary Islands, which are 16 degrees west longitude. There basically is nothing out there except one thing that I found on Google Maps, and it's the Cape Verde Islands, the only thing I could find. But if you read the textbooks, the Cape Verde Islands were discovered by the Portuguese in 1460. So this didn't seem right, but somehow this appears, by magic as a prime meridian in this table of latitudes and longitudes. In addition, okay, so now I don't know if I should read through all this stuff here, but there was an Arab geographer polymath named al-Biruni who lived in the 11th century, and he talks about the scheme of the Greeks who used the Acumen and the extremity, the westernmost extremity for the longitude of the count being based on its distance from the west. And there's disagreement among astronomers about this extremity. Some of them calculate longitude from the coast of the Western Ocean, which would be the westernmost coast of Africa, while others calculate it from the islands that lie far out in the ocean, some 200 farsakhs from the coast. So remember I told you a farsakh was 3 miles, okay? So 600 miles off the coast of Africa. These islands, known as the Fortunate Islands and the Eternal Islands, are off the coast of the country of the Maghreb, which is basically North Africa here. And so basically, both in that table and by the reckoning of al-Biruni, there's a perfect match for the Cape Verde Islands. So the Arabs evidently in the 12th century knew about the Cape Verde Islands and in the schema used it as the source of their prime meridian. So that's my talk, and I'm sorry if I pushed the boundaries. Apologies. I have some ongoing projects, and I could talk about them if people are curious. So thank you.
We have time for a few questions. I'll come around with the microphone. Raise your hand. We're videotaping and live streaming, so we want to be sure to get your question, the audio of your question. Yes.
Hi. Do you watch The Big Bang Theory? And what do you, if you do, what do you think of the science principles that are used on the show?
I don't watch it much, but I'm a friend of the guy who's the consultant. And the guy who's the consultant is a physicist at UCLA. And actually, a lot of the equations on the blackboard are relatively accurate. And so I think the science is supposedly accurate. I remember, it was kind of funny. I only watched it a few times, but I remember one time, like, for a Christmas present, somebody got the Feynman lecture series. And supposedly this was like, well, what a dork. And I was thinking, well, I'd love to get the Feynman lecture series as a Christmas present. So I don't know. So yeah, I think because of the consultation with my friend, it actually tends to be fairly accurate.
What is underwater lightning?
What is underwater lightning? Should I just...
That was my question as well.
Okay. Okay, so if you want to go home and go to YouTube and put in the phrase underwater lightning project, you'll see a little experiment I did. There was an anthropologist named David Lewis who interviewed 3 different indigenous navigators in the Pacific who were widely separated, one in Tonga, one in the Gilbert Islands, one in the Eastern Solomon Islands. And they all said that when they were far out to sea at night, they would see this flash of light underwater that would point in the direction of an island. And nobody knows what it was. And there have even been modern confirmations. There is one Westerner who I work with, who claims to have seen it. What it is, I don't know. I talked with a friend of mine who is a colleague of mine who is a specialist in bioluminescence. I showed him the literature. I said, what do you think this might be? He said, when fish dart underwater in seawater that's filled with dinoflagellates, which is a single-celled organism that emits a flash of light when it's given a pressure wave, it looks a bit like what the description was. So he gave me a little flask full of dinoflagellates, thinking that it would just die on my shelf, and that would be that. But I went on the internet and learned how to grow them. So I grew about 4 liters of dinoflagellates in my basement, and I took it into the Harvard Science Center put them in a long trough, and arranged to have a little segmented fishing lure drawn through it, poured it in its daytime cycle, turned out the lights, and then in the night cycle photographed it, and darn if it didn't look like underwater lightning. So check it out on YouTube and see.
Over here on your right.
Hi. Does all of this explain modern man's inability when lost to ask for directions?
What did men do in the old days where there were no filling stations to refuse to go into to ask for directions? I can't explain the psychology until believe it or not, since I've been doing this course, I'm far less afraid or far less proud to ask for directions. Actually ask directions, and I've actually learned that it's kind of cool because you have an excuse to talk to somebody else. And you get to learn what they're doing, and it's actually kind of a nice social interaction. So I've lost that hubris, if you like, and what can I say?
Are you collaborating with indigenous wayfinders in your ongoing research?
Yeah. So I have a guy who I'm working with, Joe Gens, is an anthropologist from the University of Hawaii, and he has a guy who he has worked with, Captain Joel Corrent, who is in the Marshall Islands, and I did a lot of work with Joe trying to figure out what was going on in terms of the physics of the waves, because it turns out it's very difficult to model wave reflections, and in fact the oceanographers who went out with Captain Corrent couldn't find the reflected waves, and Captain Corrent could, and it was because the oceanographers didn't know what to look for. And so actually, being a big kayaker myself, I get close to the ocean, I was actually able to look in a videotape and see what they were missing. So we have this whole collaboration going on where we're trying to kind of sort out things, and there's a little bit of dogma, a little bit of fiction, some of it depends on the islands and that sort of stuff, so it's still going on. It's pretty cool.
What should we do about this navigational atrophy in the information age society?
Well, get out and try stuff, I guess is the best thing to do. I mean, what I do with my students is I get them to learn the positions of the major navigational stars, and I have a scheme for doing that, which is a star will pass over the zenith of a point of land like 39 degrees north. Somebody said we're at 39 degrees north, right? So, Vega has a declination of 39 degrees north. So Vega is a zenith star for Kansas City. So you can look at a patch of maybe 22 stars and actually memorize the cities for which there's zenith stars over, and then do a very similar thing with longitude. And you start to develop a picture in your head. So if I showed you a map of North America, and I turned it, just an outline of North America, and I twisted it, in some funny angle, and I say, okay, orient it so north is up, you wouldn't have a problem doing that, right? And the whole thing is that you can do the same thing with the stars in the sky, and you just have to get used to their motions and what the positions over the course of a night and over the course of a year. And you can study this sort of thing. I mean, you can actually, and you'll find your life is richer. My parents had this app where they would say, oh, I can hold this up and find a star, and they struggled. And I said, no, Sirius is over there, and Procyon's over there, and so anyway, it can be done. You just have to work at it.
All right, Dr. Huth, we have a question up front here, and due to the time, this is going to be have to be the last question because we have to start the book signing soon.
Just a silly question here, but where do you go to get a year's grant, to go to an exotic Pacific island, put a stick in the ground, and lay rocks out to determine your latitude?
Where do you get a grant? That was my dime. It was my vacation, and I just booked the reservation so that I would be in Jamaica on the equinox. And I could have, my wife. Well, actually, I have an upcoming cruise from Tahiti. You can do this with the Harvard Alumni Association. Little plug, great. So you can go from Tahiti to the Marquesas, to Mangareva, to Pitcairn, to the Easter Island, and we're doing that in the fall of 2013. And I actually going along as a quote-unquote expert, and don't ask me why, but so that's for free for me anyway. Cool. Okay.
All right, thank you for the wonderful lecture. And thank you for attending tonight's talk. Rainy Day Books has copies of The Lost Art of Finding Our Way on sale right now, and Dr. Huth will be over there in a minute to sign them.